Welcome to the show. It's the last idea for this chapter on differential equations. We're not going to do much on it because we have a semester course in it. In my book, it's 9.5. Whatever they call first order linear. In your book, first order linear differential equations, here's what makes it first order. All we have is the first derivative. And what makes it linear is only simple stuff happens to y and y prime. You don't have y prime times y. You don't have y squared. So that problem we did last video where it was the logistic, where you had change in dp dt equals p times 1 minus p, nonlinear, because you have a p times a p in that problem. This is a linear, and we can solve any first order linear. And I'm giving you the way to do it. It's not in the book. My way's better. It's shorter. But you have to do a little thing. Here's what the solution always is. Be able to use this. It's integral of e to the integral p. P is the thing that's times the y. You got to have y prime by itself. Nothing times it. And times q. Q is this term over here, plus c, all over e to the integral p. So you do e to the integral p twice. So I always run off to the side and do e to the integral p. E to the integral p in this problem is e to the negative 2 dx. Well, the integral of negative 2 is just e to the integral of negative 2 is just 2x, negative 2x. So e to the negative 2x. This is y equals, we're getting y, we're getting the solution. E to the negative x times x inside of an integral, dx plus c over e to the negative 2x. Just substituting in. Well, e to the negative 2x times e to the x, you add the exponents. Negative 2x plus x is negative x. So I have integral of e to the negative x. Got to do that integral. So that'll be negative e to the negative x plus c. And this thing is divided by e to the negative 2x, which is times e to the 2x. So I'm multiplying by e to the 2x here, and just add the exponents. So I get negative e to the x plus c e to the 2x. Initial conditions now apply. You don't do the initial value, the initial conditions until the very end. So I pop in 0 for x, y is worth 2. 0 for x here, 0 for x here. E to the 0 is always 1. So I have 2 equals negative 1 plus c, c equals 3. There's my final answer. We're going to check, because we always check. Let's do the check. The check is easy, because all you do is check to see, do you have the initial condition satisfied? And does your answer satisfy the differential equation? So if you remember from in the olden days when you were doing a problem, you have your answer, you check it in the original. Remember? You've been doing this for years. Here's your answer, check it in the original. So I'm going to take the first derivative of this. So that's y prime. The first derivative of that is going to be negative e to the x plus, and now the derivative of 3e to the 2x is 6 e to the 2x. So that's all y prime minus 2 times this thing here. So I'm going to have negative e to the x plus 3 e to the 2x. And if you notice, I have negative e to the x plus 2e to the x. So that leaves me with just a single e to the x, and the 6 e to the 2x minus 6 e to the 2x. I just get an e to the x equals e to the x, and I get a smiley face. I did okay. That's how you check a differential equation. All right, next up, we're going to do one right out of the book. New problem. This is right out of the homework in the book. This is a book problem. So this is the problem, just this top part. Looks pretty scary, but we can always solve it. It's first order. It's linear. X squared doesn't keep it from being linear because stuff can happen to x. It's the y's that have to be plain. Divide by x squared, because I got to get 1 y prime. Well, 2x divided by x squared is 2 over x. Natural log of x divided by x squared is just natural log of x divided by x squared, so that doesn't simplify. And now I can see what's going on. This is my p, and this is my q. So I have to do e to the integral of p. Integral of 2 over x is going to be 2 natural log x. Now here's the tricky part. You got to be able to do this, you guys. That 2 is like an insulator keeping these two functions from canceling. So you have to use a rule of logarithms. 2 natural log of x is the same as the natural log of x to the 2. It is a rule of logs. So you're supposed to remember that. Isn't that wild? But now these two things, these two inverse functions cancel, and I get just x squared. The e to the integral p dx is just x squared. I use that twice. I have x squared there and x squared there. And check it out. Natural log over x squared doesn't look so scary anymore, does it? These two x squareds cancel. So I'm just doing the integral of natural log of x dx plus c. Just drag that plus c along. Everybody divided by x squared. So you can do that. That's an integration by parts. In fact, it's either the first or second integration by parts we ever did. I remember it. The integral of natural log of x is x natural log of x minus x. Then plus c. Everybody's divided by x squared. Well, I can divide by x squared. I can divide by x squared from the beginning because x is equal to 1 in the initial value. So it's as if the problem starts with x equals 1. So x equals 0 is not a hassle. It's nice. So anyway, so dividing through by the x, we get this, dividing through by the x squared. That's the general solution. And we have, when x is 1, y has to be 2. So when x is 1, natural log of 1 is 0. So this is negative 1 over 1 plus c over 1. So I have 2, that's the y value. Remember y, way over here. Y equals all this stuff. Y equals negative 1 plus c. C has to be 3. So that gives me my answer. I can write my answer right now. Let's write this answer. Y is equal to natural log of x over x minus 1 over x plus 3 over x squared. Now, what are you supposed to do with this? Well, you can go in the back of the book and check, but what if it's for a grade? We're going to find out how to check. Sup? The coolest thing you can ever do is check an answer. I would bet money right now that there's a person in this room who one day will be presenting a piece of work to a supervisor or explaining something to a coworker, and that you checked, and the supervisor or coworker said, "Did you check this? Because it's really beautiful." And you say, "Yeah, here's the check." And they're going to say, "You already checked it before you presented. Good job. That's the right thing to do. That's a smart thing to do." Nobody checks anything. They're all lazy as hell. So here's the problem. This is the original problem, remember? Here's our answer. That's where we left off a second ago. I take the derivative of this, which is over here. I take the derivative. So I'm thinking of this thing here as 1 over x times natural log of x. And I'm thinking of this as 3 times x to the negative 2. I'm thinking of this as negative 1 times x to the negative 1. So take the derivative very carefully. You got to do product rule on this. So I get 2 terms out of it. And then the derivative of negative 1 over x squared is plus 1x squared, 1 over x squared. And then the derivative of 3x to the negative 2 is negative 6x to the negative 3. It's all over there on the right. Now you take that whole pile, you take that whole piece. Let me see if I can get my hands around this whole piece over here, and you put that in for y prime. See, x squared y prime? So you put that in for y prime. How do you ever check your answers? You take the answer and you put it in the original. Well, here's the answer. You put it in the original. Well, I can't put y in for y prime. You put y prime in for y prime. But y goes here. So here's y prime times x squared plus 2x times y. And a beautiful thing happens because you did it right. Watch this stuff. So the x squareds cancel, and I have just negative natural log of x. The x squareds cancel. I have 2. And the x squared goes into the x cubed, leaving a negative 6 over x. So that's the first piece. Now look at the other side. So this piece here, the x's cancel. I get 2 natural log of x. The x's cancel. I get minus 2. And then I have 3 over x squared times a 2x. So 1x cancels, and I have 6 over x. And check it out. 2 natural log of x minus 1 natural log of x is 1 natural log of x. 2 minus 2 is 0. Negative 6x plus 6x is 0. This thing satisfies that differential equation. You got it right. That's what it feels like. You don't have to go to the back of the book and look. I would please beg you to do some problems from 9.5 and check them yourself. It is so good for you. So that's your work this week. We'll be having a test on differential equations. It's a quickie, but I won't give it to you before Easter. Probably right after Easter Monday or so. I'll slip a practice test to you at the end of this week, and then so anyway, differential equations. You have to be able to do separable, first order, use initial conditions, and I think that's about it. Yeah. So don't worry about all the fancy direction fields. Without a computer, I can't ask you those questions. And we're not going to the computer lab anytime soon. So I'll see you all out there.